Thank you for joining us today at HAProxy Conference 2025 here in beautiful San Francisco. We are excited to share our journey at Liftoff and discuss how we leverage HAProxy to simplify, scale, and secure our modern applications. My name is Tommy Nguyen. I'm a technical manager at Liftoff, and joining me today is my coworker, Ken Chin, senior software engineer. Together, we will walk you through the challenges we face, the solution we implement, and the lessons we learn along the way as we evolve our infrastructure with HAProxy. Whether you are just starting out with HAProxy or looking to optimize your existing setup, we hope our story provides valuable insights and practical takeaways so you can apply to your own environment. So let's get started. Here is the agenda for today. First, I will introduce a bit about my company, Liftoff, and then we talk about how we started with HAProxy, and then some event happened, which the changes are much needed, and the future of HAProxy, and then Q&A. First of all, let me talk a bit about Liftoff, where Ken and I are currently working. We are a mobile advertising service company founded back in 2012 and based in Redwood City, California. At Liftoff, our mission is straightforward. We connect people with the mobile products and services they love to use. Everything we build, from our machine learning algorithms to our ad creative tools, is designed to make that connection as seamless and relevant as possible. We support over 275 million daily unique devices, touching nearly 1 billion mobile users every month across 150 geographies. Our platform processes 1.5 trillion bit requests from buyers each month, serving 300 billion impressions annually. This massive footprint ensures customer apps can achieve both depth in key markets and breadth around the globe. Now that you have a sense on who we are at Liftoff, let's set the stage for today's talk. First, we want to highlight HAProxy, which is recognized as the world's fastest and most widely used software load balancer. Its performance and reliability have made it a cornerstone for countless organizations across the globe, including Liftoff. At Liftoff, we leverage HAProxy to simplify our infrastructure, scale our services efficiently, and ensure our applications remain secure and resilient. In today's sections, we will walk you through our migration story, share how we integrated HAProxy with Kubernetes, and discuss what the future holds for us as we continue to innovate with HAProxy at the core of our platform. Now, let's take a look at how HAProxy was first introduced at Liftoff. In this section, we will walk through the early days of our adoption, the initial motivations behind choosing HAProxy, and the key factors that shape our decision-making process. As an ad tech company, Liftoff handles a massive volume of inbound requests and operate under strict low latency requirements. Our previous proxy vendor offered a solid enterprise solution, but we began to encounter several challenges that prompted us to rethink our approach. First, the operational costs were high. As our traffic increased, so did our expenses, making it harder to scale efficiently. Second, we lacked flexibility and control. Because the proxy was a managed service, we couldn't easily adjust configurations or security policies to fit our needs. This slowed down our ability to innovate and respond quickly to incidents. Third, integrating the vendor's proxy with our cloud-native environment added unnecessary complexity. Even routine changes require coordination with the vendor, which led to longer deployment cycles and more work for our teams. We were also concerned about vendor lock-in. Rely on a proprietary platform make it difficult to adopt new technologies or change our architecture as our business evolves. And finally, performance was an issue. Since the proxy operated outside of our infrastructure, it introduced extra network hops and latency, something we couldn't afford with our strict latency requirements. All of these challenges motivated us to look for a solution that was more flexible, cost-effective, and high-performing. That's what led us to HAProxy. After running into these challenges with the vendor, we realized it was the time to step back and think carefully about next step. Our infrastructure had reached a turning point, and we need to look at all the options out there to make sure we could meet our goals for performance, scalability, and operation. As we look at our options, HAProxy quickly stood out. We had used HAProxy before, but only for a short time and not in the best way. Back then, it was just a quick fix, not a real solution. This time, we knew exactly what we needed. We decided to give HAProxy another try, but to do it right, by building a strong, well-designed setup that could handle Liftoff's busy attack traffic. This was the start of our journey to make HAProxy a key part of our system. We wanted something flexible, cost-effective, and fast. It took us about 6 months to go from testing to having a solution ready for production users. During this time, we ran a lot of tests, checked HAProxy's performance, and make sure it met all our needs. We didn't rush. We took the time to plan the migration carefully, fix any risks, and make sure everything would work smoothly in production. This meant working closely with different teams, improving our settings, and building the tools we needed for automation and monitoring. By the end, we had moved from just testing HAProxy to run it as a reliable, well-documented, and scalable part of our infrastructure, ready to support our Liftoff attack needs. Let me show you how we set up our first version of HAProxy and how it works in Liftoff. First part, building and setting up. We use GitHub Action to start our building process. With HashiCorp Packer, we create machine images that already have everything we need, like HAProxy, monitoring tools, and logging tools. Ansible helps us to install and configure everything the same way on every server, creating and managing servers. After the image is ready, we use infrastructure as code to create and manage our servers and network settings, such as EC2 instances, IP addresses, and DNS record. This setup makes it easy to add or remove servers as needed. For our backend services, we use AWS Network Load Balancer, NLBs, as target groups. Each backend service is registered with an NLB, which manages and distributes traffic to the available server. HAProxy forwards requests to this NLB, and the NLBs handle routing to the backend server automatically. This setup allows backend changes to be managed efficiently without manual updates. And then you might ask how the traffic flows in this case. When users send requests, Route 53 DNS direct them to our HAProxy server on EC2. These servers are always up to date because of the automated setup that we have. HAProxy then forwards the request to the appropriate backend through the NLBs, which are connected to our Kubernetes cluster spread across multiple AZ for high availability. Automation and scaling. For auto-scaling, we use a vendor solution that is tightly integrated with AWS. This allows our infrastructure to automatically scale up and down based on demand. GitHub Action and Terraform handle the setup and configuration of new servers, while Route 53, HAProxy, and NLBs manage backend chain efficiently. In short, this setup gives us a reliable, automated, and scalable HAProxy system. It ensures fast and dependable traffic management for Liftoff workloads, while also giving us the flexibility to adapt as our infrastructure grows and changes. Here's some results from the migration that we achieved. We reduced our cost dramatically at 87.6% reduction. Latency improved by 75%, which was transformative for our attack workloads, where both cost efficiency and low latency are critical. Additionally, moving to an in-house setup empower our team to be far more agile. Previously, making configuration changes could take an entire sprint. Now, with our own HAProxy infrastructure, we can implement and deploy changes in just one day, leading to 93% faster turnaround and significantly boosting our productivity. That essentially wraps up phase one of our HAProxy journey, where we successfully migrated from our previous vendor to a fully managed HAProxy setup. For a while, everything ran smoothly and met our expectations for performance and reliability. With this, I will pass it to Ken to talk about the challenges and the issues we face after significant growth in business.
Great. Thanks so much, Tommy. We eventually encountered a major incident that became a turning point for our team. One day, our traffic setup experienced a critical failure, and we were unable to restore it to a functional state after several hours. This outage was significant, especially given the scale and latency requirements for our ad tech platform. The root of the problem was a lack of visibility into one of our key components into our stack. When traffic flows was having an ongoing issue, we didn't have the necessary monitoring or observability in place to quickly identify the exact cause. This blind spot made troubleshooting extremely difficult and prolonged the downtime. This incident highlighted the importance of deep observability and robust monitoring in our infrastructure. It was a wake-up call that pushed us to move on to the next chapter of our HAProxy journey. In our previous setup, AWS network load balancers sat between HAProxy and our backend services. This added extra layers of complexity and potential points of failure, as well as additional latency in our traffic flow. With our new modern approach, we moved to a flatter network architecture. We integrated a dynamic service discovery, allowing HAProxy to automatically detect and route traffic to healthy backend Kubernetes pods in real time. The result is a simpler, more robust, and highly responsive system that adapts quickly to changes in our backend environment, delivering lower latency, greater reliability for our ad tech workloads. So this is our previous setup, and then on the next slide here is the second iteration. So starting from the top left-hand corner there, you'll notice that Ansible is still there, Packer is also still there, and GitHub Actions is still there. So pretty much everything in this part of the pipeline remains the same as before. Since not much has changed there, we won't go too deep into it, and instead we'll focus on what was new and different in our updated setup. Now here's where things get really interesting compared to our old setup with service discovery. We've integrated console on the right-hand side over there, which means every backend service running in our EKS clusters register themselves into console's catalog automatically. Console keeps track of all the healthy pods and updates its SRV records in real time. HAProxy talks directly to console, so it always knows where exactly to send traffic, no more manual updates or stale configs. When a request comes in from the internet, Route 53 sends it to one of our HAProxy EC2 instances. From there, HAProxy connects straight to the backend pods in our EKS clusters, using the info retrieved from console. This flatter network design means there is no extra hops or layers in the way, which really helps keep our latency low and our troubleshooting simple. Console is also constantly checking the health of our backend pods. If something goes wrong, it automatically pulls unhealthy endpoints out of rotation, so HAProxy only sends traffic to pods that are up and running. Now let's talk about how this compares to what we had before. In our legacy setup, we had AWS network load balancers sitting between HAProxy and our backends. This added extra layers, more complexity, and more places where things could go wrong. Service discovery was mostly static, so if something changed in our backend, it often meant manual updates or waiting for the vendor to catch up. Traffic also had to pass through the NLBs before reaching our backend pods, which not only added latency, but also made troubleshooting a lot harder. So with our new setup, it's a whole different story. We have a flatter network. HAProxy talks directly to the backend pods. Service discovery is fully dynamic thanks to console. As soon as a new pod comes online, it registers itself, and HAProxy can start sending traffic to it right away. If a pod goes down, it's automatically removed. No more waiting, no more manual intervention, and no more unnecessary layers. So the result, we've made our infrastructure simpler, faster, and more reliable. We can scale up or down easily, respond to changes instantly, and keep our latency low, which is exactly what we needed for our ad tech workloads. Although cost savings weren't our main motivation for making these changes, we did see an additional 20% reduction in our operation costs just by removing that extra abstraction layer between HAProxy and our backends. That's a nice bonus on top of other improvements. But what's even more important is the visibility that we gained. With this setup, we now have full end-to-end observability from the moment a request hits HAProxy all the way through to when it reaches our storage. This level of transparency also makes it easy to troubleshoot, optimize, and ensure reliability across our entire stack. If you remember the diagram, you may notice another big advantage, that our architecture is more cloud agnostic. We've minimized our reliance on specific cloud provider components, which gives us more flexibility. We're not locked into any one vendor, and we can adapt or migrate much more easily if our needs change in the future. This makes our setup not just more efficient, but also more future-proof. Here we have an example of some of our Grafana dashboards. So we've taken the Grafana template that was provided by HAProxy. We've modified it a little bit, and we track various metrics from our Prometheus, from our HAProxy servers. So we enable PromX with HAProxy, and then with Prometheus metrics, we're able to present our data in Grafana. So we observe things like our HAProxy counts, our connection rates, our backend times, our latency, etc., as well as our various HTTP codes responses. We're also keeping track of our console catalog. So we're keeping track and monitoring our catalog counts as they go throughout our day. Our traffic is really predictable, so we're able to have some good week-over-week metrics. You may also notice kind of there at the top logs as well. So with HAProxy, We've enabled low-key logging, so we take our logs out of HAProxy and ingest them into our low-key for also querying and being able to observe HAProxy logs within Grafana. That pretty much sums up our second major improvement that we made to our setup. I'll share what we're aiming for HAProxy both in the near future, down the road. First off, we already have a concrete plan to upgrade HAProxy to version 3.0. Our goal is to take advantage of the latest features and improvements that we can really use to benefit our cause. There are a few key features that we're especially excited about. For example, the new glitch limit functionality, enhanced logging capabilities, advanced fetch methods, stick table enhancements, and improved traffic prioritization. These are all important upgrades that will help us operate more efficiently, gain deeper insights, and better manage our traffic. Once we're able to fully migrate to HAProxy 3.0 with some of these features, we're confident that these will make a significant positive impact on our platform and help us continue to deliver the low latency, high performance service that our business depends on. Building on our move to HAProxy 3.x, we're implementing several key advancements in our configuration and scaling strategies. So in this diagram, there's some things that are different, highlighted in green. And for maybe those that are maybe colorblind, it's the top right-hand corner, the multiple clusters in the middle, and the left-hand side, bottom left-hand corner. First, we're planning on transitioning away from relying on a third-party auto-scaling solution. So this gives us more control and predictability over how our HAProxy instances scale based on our vendor traffic patterns, instance availability, as well as reducing costs for our third-party vendors. Secondly, we're now grouping multiple HAProxy instances based on their traffic destination, so in the middle. This allows us to optimize routing and resource allocation for different services, ensuring each service receives the necessary capacity and performance. For example, we can dedicate specific HAProxy groups to high traffic or lower latency applications. This also helps in cost attribution to better define the costs per traffic. Finally, we're beginning to look into our GitHub workflows to generate configuration artifacts that HAProxy can directly load. This includes opt files and vert files, streamlining our configuration management and ensuring consistency across our deployments. This reduces the risk of manual errors and allows for faster configuration updates and rollouts. These changes combined represent a significant step forward in how we manage and scale HAProxy, enabling greater efficiency, flexibility, and reliability in our ad tech workloads. As we come to a close to our presentation, we'd like to thank everyone for your attention and participation, but don't go just yet, because Tommy has one final exciting thing to share.
Thanks, Ken. I want to touch on something that's still a bit early for us, but definitely exciting. As we all know, LLMs and generative AI has become huge topics. Everyone's talking about AI these days. And there's a lot of expectation that AI will make existing solutions even better and help us serve users in new ways. With that in mind, I think there's a lot of potential for HAProxy to evolve and integrate more closely with GenAI technologies. In fact, HAProxy already supports running as a native AI gateway, which open up some really interesting possibilities. When we look at the current landscape, we see solutions like OpenRouter and OpenAI compatible APIs gaining traction. And I believe this is a very promising area for HAProxy to expand into as well. So while it's still early days, we are keeping a close eye on how HAProxy can play a bigger role in the AI ecosystem. Whether that's by enhancing its own capability with AI, or by acting as a high-performance gateway for AI-powered services. It's an exciting space, and we are looking forward to see how it develops. And as you can see in a screenshot here, it's a community HAProxy MCP server, which I can use any MCP client or a chatbot to connect to the server and then fetch the HAProxy information, like the status of the node of the cluster. And then finally, here are lesson learned and takeaways. First, observability is absolutely crucial. Without a solid observability platform, things can go wrong very quickly. And when they do, it becomes incredibly difficult to debug and troubleshoot. Investing in full end-to-end observability from the HAProxy layer all the way to every component in system is critical for maintaining reliability and quickly identify root causes when issues arise. Second, over the last 5 years of running, upgrading, and enhancing HAProxy, we have learned that this kind of transformation is never just the work of a single team. It's a true cross-functional effort. Our success has come from a strong partnership across the organization, especially with our developers. They have been involved in every step, from design to implementation, bringing their perspective and feedback to the table. This collaboration ensures that our setup isn't just optimized for infrastructure, but also truly meets the needs of our users and applications. And finally, HAProxy has really enabled Liftoff to simplify, scale, and secure our entire infrastructure. It helps us streamline our operations, handle growth with confidence, and ensure that our platform stays reliable and protected, all while giving us the flexibility to keep evolving for the future. And that's the end of the presentation. Thanks, everyone.
Thank you.
Awesome, great talk, guys. So we probably have time for maybe 1 or 2 questions. So if we have any in the audience, again, put your hand straight up. We did have one in the stream. What was the process like removing AWS NLB?
Yeah, I can take that. So the process is not easy. Like I mentioned in the slide, we go through pretty rigorous testing for 1 or 2 quarters just to test out. And then we go to the POC, and I think the most critical part is how we handle the rollout process. So at first we have the blueprint deployment, and then at any point of time there will be an old deployment and new deployment, and then we ship the traffic over slowly once the testing is done. And then that one is the truly zero downtime deployment as well. Yeah.
Excellent. Okay, I'm sure if others have questions, they can find you here in one of the breaks or tomorrow. So everyone, please give it up again for Tommy and Ken. Thank you.